Let's get started with Spyroscope. Unofficial Spyroscope. I'll be honest, it'll take a while for me to ingrain in my mind, but please refer it as unofficial with the best of your ability as well. We need to grab the program from GitHub, which is where it's stored alongside its source code. In the releases page, I'll be grabbing the latest public version that's currently available. It was actually left in draft for a very long time. I'll leave a link in the description to the releases page of the GitHub repository. Download the zip, extract it, and run the executable. Depending on how paranoid your operating system is, you might see a pop-up. I can't do much about avoiding that, so we'll have to tell it to calm down and let us run it. This is how it will first appear when you open it up. As it states, it's currently waiting for an emulator to attach to. At the moment, only a select few emulators of specific version will work with the tool. It is not strictly limited to those since you can add your own if you need it. Let's open up one of the supported emulators and prepare a game. Each of those steps the program will recognize and then expect the next thing it requires to run. It should be able to discern the game you are about to load and write it out in the initial setup and eventually into the title bar of the window. As for now, what I recommend you do first is at least load a level in the game so that the program has something to look at as it expects a level to be loaded already. Once the program can finally understand what it is seeing, we can finally use it. The first thing you can do is take advantage of the free camera movement. By holding right-click, you can use WASD and mouse to move your view around the level. If you feel the default speed of moving around is not satisfactory, you can use the scroll wheel to adjust the speed. If you want to temporarily speed up, you can hold down the left control key. What's neat about this is that, by default, this affects the game view as well. So if you wanted to take screenshots of the game itself from different impossible points of views, you could do it with this. You may have also noticed two buttons on top that look like a play and pause symbols. These affect the game update loop. This is not the same as pausing the game at emulator level, since in here the game is allowed to continue to render to the screen. Pressing P will also toggle the pause state. While paused, we can still move the camera around and observe the current state of the level and objects. In case timing yourself to pause at a specific state of something is too time sensitive, there is also a way to advance the game by 1 frame. An object, or Moby as they are also called, are generally represented by these small 3D axes, and some may have a model displayed. They can be clicked on to see further details about them. After selecting, by moving the mouse to the right edge of the window, the inspector panel will slide open. The first row will show the RAM address that holds all of the following basic info below that describe this object. You can use this value to directly jump to the location in the emulator's RAM in case the data you are looking for is not displayed by this tool. Some of the parameters can be modified to see what changes about it in the game if you don't want to directly write values into the memory. The labels applied to this inspector are based off of interpretation and not actual internal names, meaning if you have a better name for them, I suggest submitting an issue. The pieces of data that is specific to the object type are at the address that the data value shows, which currently is not interpreted by the unofficial Spyroscope into the inspector. But you can manually go into the address location in the emulator's RAM and try to tinker around with the bytes. Oh, and if you don't like the panel hiding itself after selecting an object, you can pin it using this button. There's also another hidden panel in the top left corner of the window that can change the appearance of what we are seeing among other things. There are 4 groups of options that are related to camera, scene, object, and some extras. The camera option allows you to change your point of view from within the program. You can have it mimic the game's camera, have a separate free view from the game, lock the view relative to Spyro, or have a top-down map-like view that matches the minimap in the game. You can also decouple the in-game camera's behavior with the free game camera toggle. The shortcut for it is C. If you're tired of seeing the plain white geometry and wireframe of the level, head on over to the next set of options. Here we can change the appearance of the terrain geometry. Currently we've been looking at the collision geometry this whole time. You can toggle whether the solid or wireframe can be viewed together, independently, or none at all. The Show Grid toggle shows the optimization used in the game for collision checking between the terrain and objects, so that only relevant triangles nearby are only looked at. Whichever solid triangle is and will be present will have a line drawn from its center to the cell center. There are different types of overlays we can apply to help distinguish parts of the terrain. Collision flags are applied to triangles that have special properties like portals, invisible barriers, ladders, various types of hazards, and modifiers that affect Spyro's movement on the ground. The form animation of the geometry can be seen, as well as some additional info about them can be looked at by clicking on one and looking at the bottom left. The water overlay is pretty self-explanatory. It shows surfaces where you can dive under and jump out from the water areas. Sounds of certain triangles when walked over can be different and is shown here. And finally, the platform overlay. This one is not particularly read from any extra data, but calculated based off of the game's math. I had hoped speedrunners would find this useful for finding new places to jump to and from. I've been told, however, this overlay is not entirely accurate, but it does the majority of its job well. Back to the render mode, the remaining options are related to the visual representation of the terrain. The first of them is what you would see if portion of the geometry is far, low poly, and only vertex color. Sometimes is used to fake fog in the game. The next two are colored and textured, and are normally closer to you to see. Both use the same set of high poly geometry, but have two sets of textures depending on its distance. You can also click a face of one of them and see in the inspector a bit how that face is made up. In Unofficial Spyro, however, I adjusted the textures to allow seeing the full quad of it on the geometry, rather than 1 pixel less as it is seen in the game. So it's not entirely accurate in that sense. While in these modes, you can filter out what portions of the rendering you would like to see. Vertex colors, textures, base geometry data before it gets modified by other means like animations, and another set of vertex colors that are used to help transition between the near and far sets of geometry. The next mode mimics what the game tries to render based off of the game's perspective. It will change the region of the terrain to an appropriate level of detail depending on its distance and will not render those that are out of view. This is better viewed in the program where it's not attached to the game's camera. While in the previously aforementioned modes, the skybox will also render. And finally, the last mode is a visualization of the differences between what is being rendered and what you can collide into. Red and green show deviations of the surface in and out respectively, while pink and cyan show a lack of collision and visuals respectively. The next group of options are a bunch of toggles that show the visibility of objects and possibly extras attached to them. At this point, we have reached my experimentation phase back then, since as you will see, not all of them have been properly implemented yet or could be scrapped. Object origins and models can have their visibility toggled on and off, though not all models are currently supported, especially from the first Spyro game. If an object has not been unloaded but disabled or hidden by the game, you can still view it by enabling inactive objects. Icons for only gems and containers can be shown on top of everything when toggling display icons. This is especially useful for locating the remaining gems, even though that type of feature is present in some of its games, or for those looking at everything from the top-down map point of view. The remaining options group has ways to mess around with the game. The manipulator is just a translation tool that allows you to move things with the position around. The object space option is just a modifier for the tool. It just aligns its axes with the object orientation. A basic teleport action for Spyro, whose shortcut is T, and an experimental replay feature which can be enabled immediately by hitting the record button or using the shortcut R. It will only record Spyro's actions, so if there are different elements that were interacted with during the recording, it will get desynced or not make sense upon replay. Pressing record again will pause the recording. With what is recorded so far, you can see several new things. The bottom now shows a timeline from which you can play, shortcut is F, scrub through, clear, or clip off at either direction from the current time frame. You can see the button inputs you used throughout the recording, as well as the lateral and vertical speeds represented by the red and green line graph. There is also a path line in the level where you can see the individual position steps as Spyro traveled. Within the path, there are arrows that mark every second of the recording and dividing lines that represent a state change Spyro has undergone. If you had played it back or scrubbed through it, and you want to regain control of Spyro since he is currently frozen in time, you can hit the stop button that is in the timeline. Now for some hotkeys that were implemented but not mentioned or used in the UI. 9 key on the number row exports to terrain. You will have to use my quick and dirty Blender plugin to get the model out from the exported file. There will be no textures, however. We will get to that soon. In fact, the last hotkey, V, brings you to the VRAM view. Pressing V again will return you back to normal view, but I will explain what you are seeing currently and can do. Here you can see what the emulator stores in its VRAM. Although what you are seeing here in Unofficial Spyro is actually augmented, the data store would normally look like this. It's actually messy looking, but that is because the textures are encoded in a special way using color lookup tables, or index colors. In the program, you can hold right-click to pan around and scroll or zoom. Moving the cursor around, you can see in the top left the pixel coordinate it is at and the current T-page index. The textures look a little squished. Let's stretch it really quick by pressing the 1 key on the number row to toggle it. Hovering over texture quads will reveal what color lookup tables it is using, and vice versa. Clicking on a texture quad will show what other textures and color lookup tables are related to it. The larger textures are usually divided into 4 smaller ones. You can see what corner they would occupy with the blue edges. If you somehow strayed far from the VRAM region, you can jump back with the 0 key on the number row. Finally, to export these decoded textures, you can either press the Export VRAM button or using the number 9 key. You can also press the Export Terrain Only button if you want them neatly in a grid. Now I am done with explaining the program as a whole. If you encounter any bugs or behaviors that you believe is not working as intended, I suggest you go back to the GitHub repository that you downloaded it from and submit an issue. This will help track down any remaining issues Unofficial Spyro has. You may also notice a few parts of the program I skip over as I go through the UI since they either broke or were left half implemented. You can check previous versions if you'd like to see where it was before this video. Again, this tool is not perfect, and unfortunately I do not want to focus too much time on it anymore, as I have mentioned in a previous video. Anyone could pick it up and could continue where I left off since I have left it open source. I hope I left a good framework and a good amount of comments, despite having possibly some questionable programming practices. If there are any questions, I will try my best to answer most of them in the comments. Otherwise, it was a pleasure making this tool for everyone.